it is time for some math modeling with parametric equations. So make sure you are strapped with your TI-84, a Dixon Ticonderoga #2 pencil, or your preferred writing utensil, your cabezas, your brains. That's head, but whatever. Let's dive into it. So we have a curved projectile. Now in calculus, you would actually be able to figure out these equations. But if we have the path of a projectile fired at an inclination of theta to the horizontal axis at an initial speed of v naught from a height h above the ground, above the horizontal, we'll say the ground in this case, you'll get these two equations. So your x here, that'd be your horizontal displacement, and then your y would be like your height, okay? So g is our constant of acceleration due to gravity. That value is 32 feet per second or 9.8 meters per second for the remainder of the world, everybody but basically us. Was it New Zealand maybe? I don't know. But that's why you always see that -16 t squared kind of thing going on. Look right here, -1/2 times g would give you the -16. Okay? So you see that quite frequently. So we could have it fired from, say, the ground or maybe from a specific height. So if that h would be 0, it's fired from the ground, but you might be up higher. Your height's taken into consideration. So let's just dive into an example rather than having all these what ifs. So we have Bob shoots an arrow with an initial speed of 88 feet per second from a height of 6 feet. And let me bring these up so we can fill them in nicely, okay? Find the parametric equations that describe the motion of the arrow as a function of time, okay? So remember, v naught, all right, that is our initial speed. I paused it just in time for the bell. So our initial speed. So I'd have 88 cosine of, it's a 30-degree angle, t. Boom. Donezo with that one for now. Or actually, you know what we could do? Cosine of 30, that's √3/2. So I could make this 88 over 2 is 44. So we could say 44 √3t. All right, get rid of the cosine, just evaluate it right off the bat. I like it. I like it a lot. Cool. How about y? So I'd have -1/2 times 32 t squared plus, and then we have our v naught, which would be 88 again, sine of 30, and it says that from a height of 6 feet. Oops, almost forgot the t. Boom. There's my equation. And we could write this one as -16 t squared plus, and then sine of 30 is 1/2. So that'd be 44 t plus 6. There we go. I like it. Now, I will go ahead and write this as our parametric here. X is equal to 44 √3t. Y is equal to -16t squared plus 44t plus 6. There we go. Nice and simplified. Looking wonderful. Great stuff. Okay. Now, let's bust out those TI-84s. All right, so as usual, make sure, in case you've used this for anything else, that you are in parametric mode. Boom. Now if I hit y equals, I can type those in. I'll do that while I pause. All righty, so we got them typed in there. Now it looks like what we want to get that table of values. So let's go to our table here, and we'll set our table. So second table set, we'll start at 0, and we're going to go with a change in the table. Looks like we want to go by 0.5s. And rather than ask, because we'll probably use this for something else where we're like asking it and just setting values, yours may already be set on auto, but I'm going to change mine to auto. So we're going to start at 0. We're going to go by halves, by 0.5, to fill out this table. And now I'm ready to rock and roll, hit second table. All right. So we got 0.6. 38.105, 24, so on and so forth. I'm going to fill those out on the chart while I pause, but you should see this right over here. If not, see if you made some kind of an error. Pause the video and go back and see if you can get those values to show up. Alrighty, so I've got my table of values filled in, and I want to take a look at something real quick, and it's this bottom value here. When we get to 3, I got a negative for my y. What does that tell me? That tells me that my height is now a negative number. That means that somewhere in here, somewhere between 2.5 and 3, we hit the ground, right? Eventually that height is 0. So I'm not even going to have that one on the table. I put it there to talk about that, but we're really going to stop this at 2.5, and then there's right after that, somewhere between 2.5 and 3 is when it hits the ground. We know that. Okay, we will be figuring that out a little bit later. But let's go ahead and plot these. I'll use a different color for plotting it now. So I've got 0, 6, which will be something like right around here. And then I've got 24, which is a little before 25, and 38-ish. So that'd be something like up here. Totally mixed up my X and Y's there. It can happen to anybody. 38, comma, 24. Somewhere in here. Then we got 76 and 34. I'm going to pause while I plot the rest of these, so to save some time. Alrighty, and there we go. We got this thing nice and plotted here. Got my arrows on there at each point to show the direction that it's taking. So this is... we have to scale it a little bit, but so the scales are different on the X and Y axes. But this is modeling the path of the ball. Okay. Now in algebra 2 or even algebra 1, when you have like a h of t equals negative 16t squared plus something blah 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 blah, that was only the height as a function of time. And although it looked kind of similar, negative parabolic in shape, that was not the path of the ball. That was the height of it as time went. Okay, this is actually the path of the ball, vertical and horizontal displacement. Okay, so kind of cool that we're actually able to do that now, even though somewhat looks the same. It was not that before. Awesome. Good to go on this. Now let's answer some questions. First question is, how long will it take the arrow to land around to the nearest thousandth? That's 3 decimal places for those of you that did not remember that. So what does it mean when the arrow is going to land? Well, that would mean that it is a height of 0, right? So if I take that y function that models my height, set that equal to 0, we'll be good to go. So I'd have 0 equals negative 16t squared. Then it was plus 44t plus 6. Now I can divide everything by 2 on each side here, which will make my numbers a little bit smaller. So if I divide all this by 2, I'll jot that down so you're not like, wait, what? Negative 8t squared plus 22t plus 3. And now I can deal with some smaller numbers in my quadratic formula. Or you can plug this into your calculator, non-parametric mode, as just your y, and find out when it's going to be 0. But I'll just go ahead and use the quadratic formula because, I mean, who doesn't love it? Negative 22 plus or minus the square root of b squared, 22 squared, minus 4 times a times c all over 2a. And let's plug that into our calculator. All right, so when I plugged this in the first time and I did the plus the square root, I got a negative answer, okay? I got negative 0.13. So that's like before time started. So I'm going to obviously have to disregard that one. So then I did it again with subtraction now. And notice how I didn't put parentheses around the negative 22 and then at the very end. I forgot to do that, so I just hit enter and then I divided by negative 16 to make sure that I'm dividing that entire numerator by negative 16. It's an easy mistake to make, even as advanced students such as yourselves. So be careful with how you're typing these into your calculator. In any event, I got 2.88. And remember when we said between 2.5 and 3 seconds on that T-chart, it went to negative? This checks out. This makes sense. Awesome. I've got my time that it landed. It would be 2.880199. So 2.880. Perfect. 2.880 seconds. Awesome. All right. Now the next question here, how far, and I feel like that's kind of messy. I'm putting the 0 there because it did say thousandth. right? 3 decimal places, even though the 0 doesn't really matter that much, or doesn't really matter. So in a math team competition, go straight comps, right? They would require all 3 of those, no matter what. So I'm going with that route. Now it says, how far horizontal distance from Bob does the arrow land? Well, we have an equation for the horizontal, right? It's that top one, the 44 root 3 t. Well, I want to know how far it's traveled. Had a mask up. Mr. Philpott joined us here. He's microwaving what looks like a steamed bag of veggies and then some chicken and some other veggies. Is that right, Mr. Philpott? Thumbs up from Mr. Philpott. All right. So I can take my horizontal displacement function here, the x right there, that is 44 root 3 t. And then since my question was, how far horizontal distance from Bob does the arrow land? I know how long it's going to take to land, that 2.880 seconds. I can just go ahead and plug that in. So I have x equals 44 root 3, and then I would plug that 2.880 unrounded, right? Because YOLO, you only round once for mathematical accuracy. Let me pop up that TI-84. Oh, no, it turned off on me. The calculator on the computer wants to save battery. So I'm just going to multiply by 44 root 3. Multiplication is commutative, so I can go ahead and just flip it and reverse it, right? I believe that's a good pop culture song. All right, so I get 219.5006, so 501. All right. Feet. I think we're in feet. Yes, we are in feet. Awesome. Next one. What is the maximum height the arrow reaches? So we're doing just a lot of like Algebra 1, Algebra 2 type stuff now with these functions. Well, I'm going to take that height function that I had, negative 16t squared plus 44t plus 6, and I can either, again, graph it, but I'd have to switch modes, or I can use negative b over 2a to get my x coordinate, which is t in this case, of my vertex to start. So let's do that. All right, so this is how long it takes to get to that max height. So what do I need to do to figure out the maximum height? I got to plug it back in. So we're going to go ahead and do that in our calculator. We would have negative 16 and then 1.375 squared plus 44 times 1.375 plus 6. So we're going to plug that all into our TI-84. All right, so as you can see there, I ended up storing 1.375 as t. It takes a little while to type in here, so it just seemed fast for me. So I got negative 16t squared plus 44t plus 6, and I get 36.25 feet. That is the max height that arrow is going to reach. Cool. So we created this parametric, we graphed that from the different parameters there. Answered a few questions, horizontal distance, height, how long it took to hit the ground, lots of good stuff there. We're going to do one more example, and then we're going to call it a day on those two, but hopefully not too crazy. A lot of Algebra 2 type stuff. Let's keep moving here. All right, so now we have a football is kicked off the ground with an initial velocity of 60 feet per second at an angle of 30 degrees again towards the goalpost that is 30 yards away. 90 feet away. Little unit conversion. Nice. Write the parabolic path of the football as parametric equations. Okay. So my horizontal displacement here, we would have 60, right? Cosine, and then 30 for my angle. T. Cool. And then for my other one, I have negative 1/2 times 32, so let's just say negative 16 t squared, and then plus we've got 60 sine of 30 t, and then it was kicked off the ground, I believe. Yep, so it's kicked off the ground, so plus 0 then in that case, right? Cool. Now let's simplify that. So we'd have x equals, cosine is root 3 over 2, so we're going to have 30 root 3t, and then y is going to be negative 16t squared, nothing to do there. Sine of 30 again is 1/2, so I'm going to have plus 30 because half of 60 is 30 t, and that's it. Yeah, no plus 0. Cool. Now, we want to find the amount of time that the football is in the air. So that means how long when it leaves the ground to when it gets back to the ground. So I'm really looking at the y function because that's going to be when is my height 0. So I want to find out when it's back to 0. So let's set that equal to 0. 0 equals negative 16t squared plus 30t. I can divide those both by 2 again, just like the last one. Negative 8t squared plus 15t. So why don't we go ahead and we could actually factor this one. That's not bad. I'd take out a t. So obviously one of the t's is going to equal 0, which isn't the one that I really want. The one that I really want is what's inside there. So negative 8t plus 15. So if I subtract 15, I'd get negative 15. Sorry for the horizontal math here. Bad form. Equals negative 8t. Divide by a negative 8. And I end up with t equals 15 over 8 or some decimal equivalent, 1.875 seconds. Okay. So that's the amount of time the football is going to be in the air, from when it leaves to when it lands. Cool. How far from the kicker will the ball land? Well, I know how long it's going to take to land. Now I can plug it into my x function here with 30 root 3 times the 1.875. And that is exact, right? We did not round that one. So let's plug that into our calculators here. So I'd have, turned off on me. Yeah, 30 root 3 times 1.875. Oops. There we go. All right. And I end up getting 4278. So 428. All right. So that's 97.428 seconds. Beautiful. Sorry. No, how far? Woo. Feet. It's like I didn't even know what I was doing, what land I was in. How far from the kicker will the ball land? After 1.875 seconds, it'll be 97.428 feet away. All right, next one. How high is the ball after 0.5 seconds? A lot of this, it's all just about which equation to use. Well, that would be my height one. So that'd be y. Think of it as y of 0.5 is equal to, and I'm just going to plug in 0.5 to that one. So negative 16. 0.5 squared plus 30 times 0.5. So I'll plug that in my calculator. And I get 11 feet. Right? Make sure we have our units right this time. All righty. So 11 feet high after a half a second. Okay. Now, here's the real kicker. That was funny. If the goalpost crossbar is 10 feet above the ground, will the kicker make the field goal? Well, that's a great question. And we got two equations here, a horizontal and a vertical. Now, if you remember back to the original problem, it was 30 yards away or 90 feet. 30 yards, 90 feet away. So let's think about how we want to figure this out. So I know how far we need to kick it. I know what the height needs to be. How about this? Let's think about, well, when will it reach that 90 foot? Okay, right? Because we know it's going to hit the ground at 97.428 feet. So it's going to go the distance, but will it be high enough up? Let's find out when it's at that 90 foot distance. Okay. So to do that, I would need to take 90 and set it equal to the, was it 40? Can't remember our equation. 30 root 3. Whew, that was close. 30 root 3 t. So when is it going to be at 90 feet? So I get 3 equals root 3 t divided by root 3. And I'll get t is equal to 1.7 732 and some change. I'm going to go ahead and store this as T. Boom. All right. So now what we want to know is, okay, well, that's how long it's going to take to get to 90 feet horizontally. How high is it at that point? That'll tell us if it crosses. So now let's go into our other equation, right? We want to know what's the height of that ball at that particular time. So I'd have negative 16 t squared plus, was it 30? Yeah, 30t. So I want to make sure that I'm plugging them in right. And I would get 2 feet. So at this point, will it make it through the uprights if they're 10 feet above the ground? No, it's going to be about 4 feet off the ground. So this is not going to make it. So, nope. So it'll be, let's see here. How do we want to word this? It will be about 4 feet off the ground when it reaches the crossbar. And that's it, folks. 2 examples. I think we'll cut it off there. A lot of calculator work, mainly just knowing what equation to use. So think about it. Are we talking horizontal? Are we talking vertical? That'll help you pick it out. But obviously, it just takes some practice, you know. All right. You guys have a wonderful day. American Freedom, rock and roll, Pasco, Riverdog Jenny on the gram, right? If you don't follow Riverdog Jenny on the gram yet, I don't know what you're doing with your life, right? You got to be following Riverdog Jenny on the gram. And YORO, especially when we're doing these problems here. You only round once, spread the word. Mathematical accuracy is key. All right. See ya.